Hi everyone, let's solve systems using GEBS. All right, so let's solve this system of two linear equations in two unknowns or variables. 4x minus y equals 13 and x minus 2y equals 5. It's a linear system because there are no x squareds or anything, right? Okay, now on an exam, I have the right to tell you to use GEBS as opposed to the other methods of chapter 7. And as a first step, you should write the augmented matrix, maybe by prepping the system first. So for those of you who benefit from putting in the missing coefficients like 1, -1, 0, that could be worth your effort. And if these are not lined up, you should line up your like terms, the x terms, the y terms, the constant terms over here. Okay, so here it's very clear what the augmented matrix is. 4, -1, 13, 1, -2, 5. Actually, going row by row might be better as opposed to going column by column if you're working with the original. Because with the original, I think there's more of a danger of thinking there's a 0 there if you're going by column. By row, if you're reading out like x minus 2y equals 5, then I think you're more likely to remember there's a 1. But whatever, start off with this augmented matrix. You don't have to write R sub 1 and R sub 2 there, but I'm using those as guides. Okay, so step 1 is fairly straightforward if you don't make a mistake. Step 2, this is the big one. Now, this is going to take up most of your time, and this could involve some strategizing. After step 2, it's pretty much automatic. But step 2 is the big step, and this is going to take up your time. You're going to apply EROs, elementary row operations, until you obtain the desired form. 1's along the main diagonal and 0's all below. So we're aiming for this. This is kind of like the target back in those trig identities. We're aiming for that form, where the question marks represent kind of like wildcards. Bear in mind, we can get this form if and only if there is a unique solution, one unique solution to the system. And remember the categories, the 3 categories of EROs. Let's review them. What were they? Row switching or row reordering in general. Row rescaling. You can multiply or divide through a row by any non-zero number. And maybe the addition and rescaling method, in the sense that you multiply, well, bottom line, you can add a multiple of one row to another. You can add a multiple of one row to another, which combines the idea of rescaling and the addition method, the idea of adding equals to equals. Now, you could apply a sequence of steps, get row equivalent matrices in one way to get this. Your friend, your study buddy might do it another way. And you two could both be perfectly correct. In fact, your matrix here might be a bit different from your friend's matrix, and you could both be correct. Now, on an exam, I'm likely to say that I want your final matrix in row-echelon form, which means I do want 1s along the main diagonal. Some books relax that restriction. And in practice, sometimes it's easier to have these not be 1s. But since on the final, I will typically ask for row-echelon form for your final matrix. Assuming you can get this form, assuming there is one unique solution, I will expect 1s on the main diagonal if I'm asking for row-echelon form, which I probably will. All right. Now, let's see here. So we have here this matrix, right? And we are going to do what? Our goal is to reach this matrix over here, right? So what do we want? We want to have a 1 in the upper left entry. A 1 in the upper left entry. Now, what's the fastest way of doing that? Think of it. There are a couple ways you can accomplish that. So what are a couple of ways of accomplishing that? Well, one way is that you could divide the top row by 4 or multiply by 1/4. That would be totally legitimate, but then you'd get fractions here, which aren't wrong, of course, but maybe you like to avoid them. Can you see an easier way of getting a 1 up there using an row? Huh? How about switching the two rows? Switching the two rows. All right. And that's a pretty quick way of getting a 1 in the upper left corner, which is what we like. Again, I do strongly recommend that you indicate the row operation you're applying somehow. I'm not going to really grade on that, but let's say you get an answer wrong, you get the wrong solution or solution set for this problem. It would help both me and you a lot if you were to indicate what steps you have so that both you and I could look back and try to debug the thing, right? It would help both you and me. So I would recommend doing that. It would help you organize your work and remember what you did. All right. So we have a 1 in the upper left. Great. What else do we need? That 4 in boldface, we need that to be a what? We need that to be a 0. All right. Well, how do we make this into a 0? Switching won't help. You're not allowed to multiply by 0. Remember, don't think about multiplying by 0. You're not allowed to do that. So we're really left with one clear option here, right? Which is that we're going to use that hard to name thing, the addition rescaling method. You can add a multiple of one row to another. We add a multiple of row 1 to row 2 to make that a 0 down there. All right. So here's my question to you. Before you add the top row to the bottom row, what should you multiply the top row by before you add to the result to the bottom row? The goal is to make that a 0. Multiply the top row by what? How about -4, right? So then we get -4 as the multiple, and we get that to kill this off, make it a 0. Instead of writing something like this, I think this is sufficient, writing the notes down this column. I'd like you to focus on this table. I think this table would be really, really helpful. Again, the goal is to replace into row 2. You need a 0 in that bottom left entry, right? So what you're doing is you're taking the old row 2, that was the 4, -1, 13. The 4, -1, 13. You could put a slash there if it helps. And then you want to add -4 times row 1. Okay, so you go up, -4 times, let's see if, well, let's see here. All right, if you can see that. -4 times 1 is -4. -2 times -4 is +8. -4 times 5 is -20. And again, the reason why I'd rather multiply by -4 than +4 up here is that we're much better at adding. So if we'd like a -4 to knock this out, let's multiply by -4 instead of +4. Let's multiply by -4 and add. We've seen this before with long division, with vectors. We are so much better at adding because that's combining like terms than subtracting. All right. So we add, okay, we get 0, 7, -7. And that's our new row 2. Okay, 0, 7, -7. Wow, we're on our way, right? It's taking some time, but we're on our way. Look at this. Column 1 is good. Column 1 is good. We like the 1 up there. We like the 0 down there. And we'll now move to column 2 and make that good. Remember, the general strategy is that we want to go column by column in terms of making things good, right? Make column 1 good, and then make column 2 good. The idea being, again, let's say you've just cleaned the kitchen floor, you'd be very angry if someone with dirty shoes came in, right? Undoing your good work. Okay, now, the 7. We need what in that position? I want the 7 to become a what? I want it to become a 1. I want 1s along the main diagonal and 0s all below. And how can I get a 1 there? Well, switching won't help really. What about adding a multiple of the top row to the second row? Even though that's a legal operation, what's going to happen if you try that? 1 times whatever, that's going to tend to mess up the 0, right? So really, there's a fairly clear option here. Let's rescale. We want the 7 to be a 1. That means that we either divide by 7, or you could say that we're multiplying by 1/7. Books tend to like talking about multiplying, but you can talk about dividing. We divide through by 7 on the bottom, second row, and we keep the first row. Remember, you're often going to rewrite rows. So we keep row 1, 1, -2, 5. Okay. In terms of what you're doing for row 2, I think this is pretty clear. But some books say the new row 2 gets 1/7 the old row 2, something like that. But we divide row 2 by 7, and we get 0, 1, -1. And we are done, finally, with step 2. Again, your friend might have done it in a different way. Your friend might have gotten different numbers here, and your friend might have been correct. So we are good here because we have a desired form. This is known as row-echelon form, and I'll define that and describe that later on. But this is an example of row-echelon form. All right, bear in mind, computers might actually do it in a different way. Okay, so we've done the hard part, and then from now on, it's really automatic. So remember that if you look at the original system, right, we started with x's and y's, right? Like the x column there, y column here, all right, right-hand side over here. Step 3 is to write the corresponding system, the new system. Again, you might want to write these letters to remind yourself, right? Whether it's x and y or a and b or x sub 1 and x sub 2. All right, so we write the new system. X minus 2y equals 5. The first row gives us the first equation. The second row, y equals -1. I like that. We got our y right there. And why do we like this system? Take a look at the structure of this system. It's called an upper triangular system, which is very easy to solve. Remember, when we were solving 2x minus 1 equals 5, right? Then we kept on going until we got an equation whose solution set was obvious. Here, the solution set was obviously this thing. With this process, with GEBS, the idea is that we get everything down to a system, here this upper triangular system, which is very easy to solve. Y is -1. What do we do to find x? Take the -1, substitute, plug it in, and solve for x. Y equals -1, plug in, solve for x. Back-substitution. GEBS, Gaussian elimination with back-substitution. We go up this triangle. So again, when we plug into that first equation, x minus 2y equals 5, y was -1. X plus 2 equals 5. Subtract 2 from both sides, x equals 3. which is good to know. Are we done? Hey, we found x. We're done. No, you are not done yet. Remember, you're not always done just with x equals. We have to find y. All right. Well, wait a minute. We just found y. -1. Okay. Write the solution in solution set form. Okay, so x equals 3. Y equals -1. Ordered pair, x comma y, all in braces. Now, when I was saying before, x equals 3, are we done? Well, okay, that's the x coordinate. Remember, that's the second thing we found. It's kind of unusual because I think many of us are used to finding x first, usually. Here, you're finding x second, okay? We're finding x second. And still, we have to remember, oh yeah, what's y? Actually, we had to look up, right? We're going in reverse alphabetical order. If I were really mean and I gave you a system in A through Z, then you're going to find Z first, then Y, then X, and so forth. I think that's a test for road competency. To be honest, I can't do the alphabet backwards sober, so I'm in trouble. All right, anyway, that's the solution set. Observe that the order of the coordinates is the reverse, okay? X comes first, then Y. We're solving for them in reverse order, but you got to put them back in alphabetical order, right? Or whatever order is appropriate, like x1, x2, and so forth. And what can you do? You don't have to, but you can check. You don't have to, but let me tell you something. It feels really, really good if your solution checks out. During exams, I hear little cheers, and I also hear mumbled cursing. So the check can be a very emotional experience because if it doesn't check out, then you feel kind of obligated to go back and debug, right? But anyway, we could check. Okay, go in the original system before you got your dirty hands all over it, right? It's best to do in the original system. So these are the equations that the thing's got to solve, bottom line. X equals 3, y equals -1. Plug into these, all right? First one becomes 13 equals 13. Second becomes 5 equals 5. The solution checks out. So we feel great. So during the test, we can go, yay. And your neighbor might go, oh, shut up. Boo. All right. A check is optional, but you feel great. Okay, ladies and gentlemen, next time we're going to do 3 equations and 3 unknowns. Doesn't that look lovely? Next time.